So a very good morning. I would like to wish to my examiner and also supervisor. Okay, so today I would like to present, not to present, not just to show you my video demo on my final year project, performance evaluation of fault tolerance in the 6G SDN. So today I will be using this Oracle Virtual Machine VM to run my SDN controller and also infrastructure layer, where I will be choosing Mininet as my infrastructure layer and Open Daylight as SDN controller. So let's start up. Okay, so for while waiting for the startup, I will be explaining on later. I will be just using one. I will be just using one platform, which is just Ubuntu platform, to run the Mininet. Okay, so yeah, so let's wait for it. Okay, so I will need to log in first. Okay, so basically here's my front page of my Ubuntu desktop, where it shows my Firefox. This is just my preset setting, and yeah, this is my file. Okay, so without further delay, let me show you on my first step, where I will start up my SDN controller first. So we straight enter into the file name and just open in terminal and slash dot cutoff, which means that dot slash cutoff means which means that it will start after cutoff, where which is also known as the Open Daylight controller. The behind supporting script is Java. Okay, so while waiting it, we start up with the Mininet. So for Mininet, I will be just using SSH enter into the machine. Yeah, so yeah, SSH is somewhere like advanced of Telnet, improvement of Telnet, where it improved from a security bug. Okay, so enter Mininet. Yeah, so I have successfully entered Mininet actually. Okay, so yeah, my Open Daylight also successfully operated. Okay, so okay, let's see our current location first. So this is my current location where I will be staying at home Mininet. So I need for my project, I will be using custom topology, not the pre-default topology like tree, linear, or even bus topology. Okay, so I will be customize my own topology for design for my own fault tolerance. Okay, so I will be entering the Mininet custom first. Okay, okay, yeah, basically here is my platform. Okay, so we are using uh, Nano. Okay, okay, you can see here as well. Actually, I have compiled a lot of file, and yeah, I will be using log2py to see my topology. Okay, um, so I will be using Nano. You can even using Vim to access the editor. Okay, so yeah, from here it's explained from Mininet topo import topo. So this is just my device where I import in to use it. Okay, so this is my class, my topo, and this is my function. Okay, so yeah, I will be adding switch, six switch, and four. So each part host to host. So later I will be showing you my topology, and yeah, this is the link from S1 to S2 to S3, S1 to S5, and so on and so forth. So for the behind part, the class link, I will be varies the bandwidth, delay, and even the loss rate. Okay, so yeah, basically here's the things that I would like to do. From here you can see I will be, for example, I will be using bandwidth, testing for bandwidth. I will just using 100, 200, 300, and I will be just fix the value, the delay at 10 millisecond and loss rate at 0 0.1. Okay, so yeah, basically this is my thing. Okay, so I didn't change anything, so let's just proceed it. So yeah, let's start up our first network topology. So sudo nm stand for mininet, and dash custom says that I will be using custom topology instead of using tree, linear, and bus topology. So topo is my class, my topo just now I have linked it in my nano editor, and dash controller, where I will be using remote controller with the IP of 192.169.56.120 with the port at 6653. Okay, before that, let's conduct the ping first. Okay, you can see I have conducted a successful ping to every host. Okay, but now I would like to show you on my first interface. Okay, so basically here's my first interface where you can see the open daylight, and yeah, this is the features that I have pre-installed in the ODL. Okay, so yeah, you can see the nodes. The node stands for there are six connector, which means that there are six links that connect with each other. And yeah, the most important thing I would like to show is the topology part. Okay, so yeah, wait. So this is host one. I need to shift it first. Okay, from here you can actually see my topology. Okay, so yeah, just now I have made it under my nano editor. So I will link everything under here, and I somewhere like a fish topology where host one has the route to here, three route, which means that it can choose for the ODL, it will choose the shortest path. Okay, so yeah, this is my topology. Okay, let's do something first. Okay, so let me open up Xterm first. Okay, before I proceed to on my calculation on how actually I obtain my throughput, delay, round trip time, and packet loss, I will be showing you on my ping first on how actually it reroute. So ping 10.0.0.0.3. Okay, you can see actually there is a successful ping from here. Okay, so let's go. Okay, I put wait. Okay, so I put link S1 S4 down. Okay, so down. Okay, you can see it actually is stopped at here. Then 19. It start up at 25, 26, 27, 29, 30, and so on and so forth. So yeah, I can prove that actually there's a link path at here. Wait. So yeah, you can see actually I conduct at here 19 sequence with TTL 85.4. So actually it has the time to reroute to the time from 20, 21, 22, 23, 24. Actually it takes 5 sequence to actually to find another alternative path to reroute. Okay, so yeah, this is actually I conduct a ping, and actually can also conduct the iPerf test also. And right later I will be showing you when I'm going through my iPerf test. Okay, so yeah, let me first. Okay, so yeah, basically here's my thing, and okay, so I will be showing you on actually how actually I capture data from Mininet to obtain my result. Okay, so I need to open up another Mininet in order to open up the Wireshark. Okay, so I will be using SSH also. Okay, so I will be accessing another Mininet, and yeah, this one is I will be using H1 H3. Okay, before I start up my iPerf test, where what is iPerf test actually is somewhere like the TCP test, a TCP or UDP test with just a open source to conduct a TCP and UDP test. Okay, so let's go to here. We start up sudo Wireshark first. Sudo Wireshark. Okay, so let us start the Wireshark. Okay, So from here actually you can see a lot of things. So this is actually my interface. Okay, so from here actually you can see the LLDP. So LLDP actually is the open flow, the protocol where the southbound interface where the controller, how to say, the controller connect with the mininet and their communication barrier through the southbound interface, which is the open flow protocol. And in here you can see the LLDP protocol. Okay, so yeah, that's never mind. Just leave it. So we conduct my first iPerf test first. So what is iPerf dot dash SST 5566 dash I dash 2? Okay, so S means source, server, and P stands for port 5566, and I stand for the interval. And yeah, so we just start out first before we conduct the client to the server. Okay, so C stands for client, where we need to go to the destination of 10.0.0.3 and dash P 5566, and with the total time 50 uh, second. Okay, so let's go. Okay, so from here we can see actually what I mean from time interval is 0 until 2 seconds, 2 until 4 seconds, 4 until 6 seconds, and continue on and so forth until 50 seconds. Okay, so yeah, let's go back to our Wireshark. Okay, actually you can see actually black packet is the packet draw, and yeah, this is the normal transmission. Okay, wait, okay, let go for this first. So actually we can see from here the transfer and the bandwidth. So yeah, the transfer means that the packet transfer, and the bandwidth means that how actually faster mbits per second. Okay, so yeah, it's almost finished. Okay, that's fine. Okay, so yeah, you can see from 0 until 51.5 seconds, it transfer 19.4 megabytes, and yeah, the transfer speed, we can say that it's 3.16 mbits per second. Okay, so let's start from here. Okay, so actually we need to search for the TCP. Okay, okay, wait for a while it's still loading. Okay, so basically here's my TCP overall, where I have filtered it out. So first, you need to understand how actually I conduct my throughput. Okay, so we just go to the statistic part and capture file properties. Yeah, from here we can see actually records, everything times when average packets, bytes, average bytes, and even average bits. So basically, my throughput is just taking the bytes with this number 303 thousand 932 divide by our time span 155.023 with the value, then we times it, then that is our throughput. Okay, so later I will be showing you my result at the Excel file. Okay, so yeah, this is throughput. And regarding to the packet loss, we need to go to the TCP dot analysis dot loss segment. Okay, so from here we can actually see all the loss segment. Yeah, so this is basically a loss segment at here. Okay, so in order need to see the summary, we can also capture the file property. You can see actually there's 26 packet drop out of 299170. Okay, so yeah, I will be calculating the packet loss ratio in my Excel file, and later I will be showing you. Okay, so yeah, okay, so now we go back to TCP again. so it's a bit lag and I wait for it. Okay, so you can see from here actually. Okay, let me explain first. So this is my first packet where you can know from theory, we can know TCP is a three-way handshake process where we will be conducting sync and the reply from sync ACK and also ACK. Okay, so yeah. So how I actually calculate my delay is by using the sync ACK packet minus sync packet with using the time interval. So the time the delay will be using the number will be using this minus deduct by this. Okay, so we will get the delay part. And next, regarding to the round trip time, we just use the stable somewhere like here. Okay, okay, this is the ACK part where 83.76.76411734. Okay, we will just use this value minus by the first packet, which is the sync packet. Then we will get the round trip time. Okay, so yeah, let me show you my Excel file actually. Wait. Okay. Okay, so this is basically my Excel file where just now I have been telling you where I have conducting for both SDN and also traditional to compare the value where you can see this is my SDN, this is my traditional, and yeah, this is the summary of everything where I have conduct the graph, delay and round trip time. So from here you can actually see the traditional the SDN actually is performed better than traditional. And yeah, you can see from packet loss, you see the traditional part until so high and SDN just stable with one line. And the delay, you can see the traditional is higher and the SDN is lower. And same goes to round trip time. Okay, so this is SDN. No, so this is the compare of everything. So yeah, for bandwidth, so I using bandwidth 100, 200, 300, 400, and 500, so on. And regarding to the delay, same goes to 10 millisecond, 20 millisecond, 30 millisecond, 40 millisecond, and also 50 millisecond. Okay, so yeah, you can see from here also the SDN is performing better than traditional a lot. You can see the graph, the blue line and the orange line. So yeah, same goes to the backup loss. The traditional is much higher than the SDN, and the delay is somewhere not stable. Where yeah, but still can see that SDN is better at the last, still performing better than traditional, and same goes to the round trip time also. Okay, so yeah, this is overall my result and my video demo, and now I will be showing you how actually I conduct my TCP test with for torrents where I have the ability to rewrite. Okay, so yeah, the same goes to the index now. We go this first, and I need to go this first. Okay. Okay, so basically it's just okay somewhere like this, and so I will be just using until 30 seconds, okay, to wait until it's stable. Okay, 20, 21, 24, okay, 28. Okay, let's go. Okay, so you can see actually there's a hang there, 25, 28. Okay, so you can see that's actually the interval 30, 32, 0, 0, 32 until 34, so 0. Okay, so yeah, actually, yeah, because I'm making it link down, that's why it has the time to reroute it. Okay, so yeah, so this is the total time. Okay, Control C. Let's make it up again. Okay, so basically, you can see in 30 until 32 seconds, actually I made it straight immediate link down. That's why you can see that actually there's 0 byte, 0 byte, And yeah, actually this path is interval is they are finding path to the alternative path to the H3. So yeah, so this is the where it successful conduct the alternative path. So yeah, that's all from me, and I hope you enjoy this video. And yeah, so regarding the future, actually I need to do some research on actually how actually I need to conduct the link where I desire, which is not on shortest path only, where I can just customize it to the higher bandwidth, or where yeah the backup will route to the higher bandwidth, not just on shortest path. Okay, so that's all from me. Thank you for listening. Okay, hope you enjoy the presentation and my video demo. Okay, that's all from me.